So the problem states that on Codeforces, the recent action field shows that the last n posts with the recent actions, initially they are post 1 to n in the field. Also, they are infinitely many more posts not in the field, right? Which would be having a value greater than n. So when recent action happens in a post P, so if it's already present in the recent action fields, it moves from its position to the top position. Otherwise it's added to the top position and the post of the down position is removed from the recent applications. So what do we mean by that? So what would happen is that this is a queue that you are having, right? It has some processes or some tasks. So this is task 0, or like let's just give it any number. So this is 0, 1, 2, 3, 4 and 5. Now you're gonna push, let's say 6 on top of here, or 7 on top of here, right? So what would happen is that this the task at the first location would become 7, and the last task that would have been 5 over here would be pushed out, right? Now if I say I insert another task, let's say 8, so now the task at, so 8 would come at the top and the task at the last location would be pushed out. So it's similar to a queue, right? So it becomes like a queue, that this is the last task, and from here you are adding the tasks, and these tasks would get removed. So it's as easy as that. So I'll just go briefly over the code. Okay, so the in the code, what we have to do is that we need to keep track of the task that we are adding on top of it, because it's possible that for a single task or a single post we added more number of times, right? But we need to know that it has already been added to the queue, so it doesn't matter if we add to the queue second time itself, right? So for that I'm using a set over here called done. So if I'll check that if I've already pushed the task onto the queue, in that case I'll continue, I'll not do anything, right? Otherwise I'm marking the last task. So the last task available in that queue would be n-1, because we are having task from or posts from 0 to n-1. So the last task would have a value of n-1. So whenever I'll like push a task, right, what I'll do is that I'll mark the time of that particular task. So we have to tell at what time a task was removed or what time a post was removed, right? So I'll just mark its time as i+1. At the end we have to print the array. One important thing is that even if you were able to do this question on your own, right, but maybe your implementation was not that neat, or it took you time to come up with that implementation, then it's always recommended to go through the solution so that you understand if there's a better way of doing it. So I hope with that it's clear. If someone has a doubt in this implementation, he can right away ask me. All clear, guys? Guys, does anyone have a doubt in this? Okay, cool. Let's move on to problem B then. Okay, so the problem B is equalize by divide. Now this is the interesting problem. So the problem states that you are given an array a1 up to an of positive integers. You can make this operation multiple times, right? So you'll select two indices which are not equal. So I cannot be equal to j, and then you'll set the value of ai as ai divided by aj. It has to be the seal division. So let's say if you're dividing 3 by 2, so the answer is 1.5. So doing a seal division, you will get the value as 2. If it's possible to make an array or all the elements of the array equal, then I can prove or they can prove that at most 30 n operations are required, where n is the size of the array. Or if it's impossible to make the operation, then you have to print -1. So that's it. That's what the question states. And in case if it's possible, then you have to tell the operations as well. So you will have to tell them that these are the set of operations that we'll do to make all the elements equal. So let's take example over here. So for this example, there's only one element that sorted it. So like we'll print that 0 operations are required. For this particular array, there are 3 elements and 3 of them are equal. So 0 operations is required again. You cannot operate on this array, because let's say if you divide 2 by 1, it will always remain a 2 itself, right? And if you divide a 1 by 2 doing a seal operation, it would again give you a value 1. So no matter what you do, the values actually don't even change. What about 5, 5? Over here, the answer also would be 0. They are same. What about 4, 3, 2? Now in 4, 3, 2, you can do 2 operations and make the elements equal. So firstly, you'll divide the element at the index 1, right? This is one base indexing with the element 3. So now this after this it would become 232, right? Now what you do is that you take any of these 2s and divide the 3 with it. So it becomes 3 divided by 2, and we do a ceil operation, so it becomes a 222. With that part being cleared, so this is the way we are going to mention the operations. So right over here they have mentioned that okay, 2 operations are required. Firstly, we'll divide the element at location 1 by the element at location 3, and then we'll divide the element at location 2 by the element at location 1. So that's it about the question. Now let's talk about the intuition. So what I'm saying is that my answer, since you guys have actually have doubts in it, so let me know if at any point of time you are unable to understand the solution. So what I'm saying is that my answer, let's say this is my array, right? And it has values a0, a1, a2, a3, a4. Now I'll firstly sort it. So that would become that a0 is less than a1 is less than a2 is less than a3 is less than a4. The intuition over here is that if I want all the elements to be same, right? So the value of them would actually lie between 1 to a1 because a0, right? Because now they're all sorted. So the minimum value of the answer, or the minimum value of the number to which all these elements can be changed, would lie between 1 and a0. Now why is this the case? Because I can definitely not increase the value of any number. So let's say I have a number x, right? Now is it possible that I divide it by any number and its value actually becomes greater than x? So this is definitely not possible. So this is one of the scenarios, right? Or this is one of the conclusions that I can make. So what I want to do is that I'll select the first element and I'll check if all the elements are equal to it. Then I already have the answer, right? But in a case all the elements are not equal to it, then what I'll do is that I'll say that okay, this is the minimum number I have. I'll try to divide any number ai with a0 till the time ai is greater than a0, right? Now why is that? Because if ai becomes less than a0, right, and if I again do a division, then ai would actually become equal to 1, because ai is less than a0, right? So when I'll divide it by a0, it would actually become something 0 point something, and when we'll seal it, so it will become 1. I want to ignore, I want that this value 1 shouldn't come in my array. The reason for that is that if I have an array wherein all the elements are 1, right, that's definitely valid. But even if one of the elements is something other than 1, right, so that becomes a problem, because now I don't have a way to make this x equal to 1. You can never do that because you'll keep dividing x by some element, right, and it will still remain x only. Now one could argue that what if like all the elements are 1 and you have 2 x's, right? Then you can do a division and then make it 1. But in that case, when you do a division of these 2 x's, so you'll anyway get 1 1 all ones 1. This x would become a 1, but this x would still remain. So even if my array has a single 1, then there's no way I can actually make all the elements equal, right? So that is the reason I want to avoid this kind of scenarios where ai is less than a0, or if ai has become less than a0, I don't want to divide it further. So that is something I'm doing, right? Also, I can prove that if ai is greater than a0 and I divide ai by a0, then it will give me a value that is minimum 2. Cool. Because it would give me a value that would be somewhere around 1 point something, at least something around 1 point something, 1.xx. And when I'll seal it, so it will give me a value 2. Now 2 is a fine value for me because I can make all the values 2, obviously, right? After doing some kind of operation, because if I take any number for that matter, let's say I take x is any number that is greater than 2. And if I have a single 2 in my entire array, then after performing x divided by 2 operation sealed, let's say a number of times, I'll definitely be able to make this particular value equal to 2. You can try this out on your own. So till this point, do you guys have any doubts? Okay, cool. Anyone? Okay, cool. So that's the entire thing I'm going to do over here. So let's look at the code. The code is also simple. Okay, here's the code for this. Yeah. Okay. Think, yeah, this was the code. This is much cleaner. Okay, this was the code for A, B, C. Yeah. Okay, so firstly what I'm doing is that I'm taking the values, right? Then I'm making a key value pair for, because I actually also want the indices. When I'm printing the operations, in that I actually want the index itself, right? So I'll be saying that I want to divide 1 by 3, or one element at 1 by element at 3, and so on. So for that I also need the indices, so I'm storing the indices also. Then I'll be sorting it. Now why I'm sorting is because, or you can actually avoid sorting it here because the function was already sorting it. But anywho, so the only reason of sorting it is that you want to know that what's the minimum element out of it, and from a minimum element you want to divide all the other elements. Now there was another way of doing it, that I could have taken the minimum element and taken its index, but anyway this looked more easy to me to do. But yeah, it definitely increases your time complexity to n square log n, n square log n. But given the time like constraints, it's fine to do it this way. Now I'll check that if the first and the last values are same. So that means all the values are same. Is that correct? Right? Because if the minimum and maximum values are same, that means the array only contains those values, right? So if that's the case, then I'll simply print out 0. In case my first element is equal to 1, or the minimum element is the array is equal to 1, and since we have already checked that 1 is not the last element, or the first element is not equal to the last element, in that case I can say that I have some 1 in my array, so it's impossible for me to make the moves. So in that case I'll print -1 itself. If these are not the case, then I'll start with a recursive solution. So the recursive solution is also simple. Firstly I'm going to sort it. After that, for all the values from 1 till n, what I'm gonna do is I'm gonna take a value, right? I'm gonna keep dividing it by the first value till the time it's greater than that, and I also have to save this operation. So I have to tell the tell the system at the end that what were the operations that I used to get till this particular point, right? Or to make all the numbers equal. So that's why I'm pushing the values. So I'm pushing the index of the ith element and the index of the 0th element. +1 over here because they're expecting in the one base indexing. And then I'm gonna make this particular element equal to the element itself divided by the first element. Now if this particular element becomes equal to the 0th element, in that case I can say that these two are same. So I'll increment my variable that's called same. After that I'll check if now all the elements have become same, right? So I can exit this recursion. Else, if all the elements are not same, I can use else over here, but not required because you already return. So else I'll again use this particular array that I've constructed after performing these all operations, and I'll again feed it to my recursive solution. I'll keep doing this. After that, at a point, all the elements would actually become same, and we'll get out of this loop, or get out of this recursion. At that time, I'll print the size of the result and the array itself. So anyone has a doubt in this, or is it clear? Who had a doubt in this particular problem? Someone actually said that let's start with B, right?
So I have a problem with my code. I don't know which test case I'm missing. I
Did
can
you
share my
do you have a
submission code.
do you have a similar code?
Yes, sir. It is somewhat similar. I have not sorted it, but first I've checked if there is any number equal to 2.
Mm-hmm.
Then I've done the recurrence in the fashion that every number will become 2. Otherwise, I've checked. Otherwise, it is moving till the time all the numbers are equal. It can be any value x. I
Cool.
can share
Yeah,
my code.
maybe we can discuss that offline. But you understood this particular logic, right?
Yes, sir.
Cool, then let's move to the problem C. The problem C is a bit tricky. I'll say it's definitely more tricky than problem D1. Let's move to that. Okay, so going to problem C. So what it states is that you are given a string. I'm not going to the statement. I hope that you have already read it, right? In case you haven't, then please go and read it on your own. So basically, the problem states that you will be given a string, and you can permute the characters, or you can make the string into any other permutation, right? After performing this permutation, you need to take the maximum of this particular string that you are giving it, or the reverse of it. So for example, if I'm giving it the string BCA, then the reverse of it is ACB, right? So whatever the maximum is of the two numbers, that you need to take that. Now the task is to minimize this particular minimize this particular string. So over here, this string was BCA, the reverse of it is ACB, right? So the maximum of them is actually BCA. When I say maximum, I am talking of lexicographically bigger or lexicographically smaller strings. So the lexicographically bigger amongst BCA and ACB is BCA. So we're going to take it. Now, is it possible for you to create any string that is lesser than BCA, and which actually satisfies this constraint that you have to take the maximum value of ACB and BCA, or whatever the permutation is? Let me try to simplify it a bit. So what it actually means is that, okay, so you had a string ABC, right? Now I could write it as ABC itself. So the opposite of it would become CBA. Let's say I permute it as BAC, then the opposite of it becomes CAB, right? Or yeah, or let me write it as maybe like ACB, then the opposite of it becomes BCA, right? Now when we'll take maximum of these, so this is the maximum, CBA. From here, CAB is the maximum. From here, BCA is the maximum, right? So which is the smallest among all of these? BCA is the smallest, right? So we'll say that BCA is my answer. So this is what we want to do. The time complexity required over here is actually order of n, or order of n log n. So how you'll do this? Now, if you start thinking about it, it always makes sense for you to like put the minimum element at the ends, right? So let's say the minimum element I'm having, or the smallest element I'm having is A, right? So I'll put it at the boundaries or at the end itself. I'll keep putting A's at the end. Let's say I have 5 A's, or let's say I have 4 A's, so I put A's at the end. Let's say I have 2 B's, so I'll put B like this. Then let's say I have 1 C, so I'll put a C like this, right? So this would be my answer. Now let's say my A was 2 and B was 2, right? In that case, and let's say my C was 0, my D was 1, or D was 2, right? So it would become A, then A at the first location, then A at the last location, then a B at the first this location, and B at over here, then a D over here, and a D over here. So these are the base cases, and these are actually easy when all the characters are actually having a even length. So this is easier to construct. The problem occurs when you have a character with a odd length, right? So let's take example. So let's say you had A, B, B. Over here, A is actually having an odd length, right? So A is occurring only one time. Now how would I place it? Would you place it at the end, or at the, or like, let's say this is the string I'm going to create. Are you going to place it at the end, or at the middle, or at the start? Where are you going to place it? That's the question, and that's what you need to figure out. Now over here, the my claim is that if it's not possible, if you are left with a single value, or a odd, like if you're left with a single frequency of a character, then try to move to the next variable that you are having. Now over here, I was having a B, right? So I'll say that it's obviously better for me if I could at least put my A to one side of the string, right? So over here, I'll say that, okay, that let's make it BBA, because then this string would be sorted, like this string would have a less value. But the problem with this approach is that although this string now has a lesser value, right? No, ABB has a lesser value, but BBA is actually not the minimum answer. The minimum answer was actually BAB over here. So how do you reach to that conclusion? So, or in other words, what I can say is that this was the strings I was already having. Let's say these were the values that were already populated, Right now you have a value of a left. So a was 5 over here. You already populated the 4 a's, but you're left with 1, right? And now let's say your b is 2, right? So how would you place it for the best answer? Would you like write it like BBA, or would you write it like BAB? Any guesses? Hi guys, any guesses?
BAB.
Why is that the case?
Because it would give the minimum.
Okay, cool. Now let's take another scenario. Let's say a was only 3. So I was having like a at the first position, a at the last position. Then let's say I was having 2 b's, right? And then 2 c's. Cool. So 2 locations for this, 2 locations for this, 1 for this. So I come to b, right? Then I say, should I now write it as BBA, or what should I write it now as?
BCACB.
Okay, so you're saying BCACB. Are you sure this is the best answer? Actually, it isn't. If you actually wrote it like this, C over here, then a C over here, then a C over here, then A over here, this would have been the best answer. So this is the point where we had to put an extra if condition, and we had to make our answer more optimal. So the condition is that if the character at which you are right now, if that is the last character possible. So by the last character I mean if it's the biggest character in the string, right? So over here the biggest character in this particular string was b itself, right? If it's the biggest character, then it makes sense for me to okay, so if it's the biggest character, then I'll actually write it as at the boundaries, right? And at the center itself, then I'll put the character that was remaining. So in case the current elements I was having was b was having 2 frequencies and the left frequency was a was 1, then I know that b is already the biggest character. There's no bigger character than this available right now, or there's no bigger character available in the string. Then I would have made it this kind of a scenario. However, if I check that okay, b has a value of 2, right, but there's also c that is having some value, or there's also some d that is having some values, then what I can say is that let me put a at one of the ends. So I'll say that whatever string was here, I'm not concerned about that. So I'm concerned about the current characters, right? So I'll say let me put a b over here and a over here. What would this do is that this particular now, okay, so when we'll start traversing from this end, we'll see a. When we'll start traversing from this end, we'll see a b over here. So naturally this particular string or this particular half is actually smaller than left, right? Because over here you'll be having some characters followed by a. Over here you'll be having some characters followed by a b. This is the right left half, this is the right half. Cool. So I know that the right half is now smaller. So now I want to make the left half smaller as well. So I cannot change these occurrences, right? So whatever string would be remaining, I'll actually sort it and write it over here itself. So let's say the characters that were remaining was, let's say there was one occurrence of b, then there was c, d, then maybe z, z, y, whatever the character was. So if I want to sort it, this would become b, c, d, y, z, z. I'll write this string exactly as it is over here. And why I'm doing this? Because I already have a over here. So this was already smaller. I wanted this particular string now. So this particular string to have the smallest value possible. And it would have the smallest value possible if I sort this particular string and write it as it is over here. That makes sense? Guys, does that make sense to you?
Yes, sir.
Any doubts on in this? I'll be like definitely sharing the solution, but if you have any doubts in the approach, let me know. Cool, let me go to the solution then. Okay, so that's what I'm doing over here. So for, okay, this is the accepted solution, yeah. Firstly, I'm taking the frequencies, right? And then I'm checking the maximum character possible, right? After that, I'm setting the two variables. So one at the starting and one at the end. This is just to populate my string. Then I'm taking my string result. I'm initially populating with all the A's. It doesn't matter whatever character you take over here, because anyway we are going to populate it in our loop itself. Then for all the characters, now there's a reason of taking a map over here and not an unordered map, because in a map your characters would already be ordered, right? And you want to start with the lowest character. Then you will check if the current is not the maximum element and you already have a character. Now what's remaining? So this remaining is like a character which I've taken, and I'll set it if the like when I'm doing this traversal and I come across a element whose frequency is odd, right? So as soon as I come across an element or a character whose frequency is odd, I'll populate. So let's say its frequency was 5 maybe, right? So 4 of those characters I'll populate. So 2 at the beginning and 2 at the end I'll populate. So there's still one character remaining that I need to adjust. So I'll put that particular character in remaining. Now what I'm gonna do is that if remaining is not equal to 1, that means there was a character that you were able that you still have to adjust, right? And if your current string is not the maximum string, so if the current character is not the last character available or is not the biggest character available, in that kind of a scenario, I already told you that for the remaining string, you'll sort the characters available to you, and then you'll add it, right? So that's what I'm gonna do. So firstly, I'll just adjust this character at the end, at the like rightmost position available right now to me. I'll adjust this character over here. I'll decrease its frequency. I'm gonna take a string use, or you can call it use me or the left over. Then I'm gonna populate the string use. So I'm gonna populate it with all the characters that have still not been utilized by me, right? After that, I'm gonna say that sort it up, and then the answer is the left part of the string that I already populated, then this use string that has now been sorted, and then the right part of the string that I populated, and then I'll return. Cool. Okay, now coming to the other logic. So till the time my f would be greater than 1, or till the time my frequency is actually greater than 1, I'll populate the beginning and the end positions by this particular character. I'll decrease the frequency by 2, and I'll keep doing it. Now it's possible that, let's say, my frequency becomes equal to 1, we'll break this particular loop. So then we'll have to check. So in that kind of a scenario, firstly I'll check if my C is maximum, right? So if my C is maximum, in that case what happens is that this is the end value that we are already working with, right? So let's say I'm already having the characters the character, let's say y with me. Now at y character, I know that the character z is all not there, so y is actually the maximum character. Now if we reach a scenario wherein the frequency is its frequency has not been made 0, or it would still actually be having some value left over. So let's say the frequency of y was 5, so you already populated 4 of them, at 2 at the beginning and 2 at the end, but you're still left with one occurrence of it, right? So you'll put that particular occurrence at the right position. And since we are talking of there's only one occurrence left, and we are already talking of the last character, so there would only be a single index left to be populated in the result string as well. So we'll populate that. Now if your f is equal to 1, right? So when would we reach over here? So we would reach only over here in case our C was max, right? So this particular if statement would not be triggered if our C wasn't max, or the current character wasn't not max. Now in case we reached over here and our C and our f is equal to 1 is also over here, then we need to populate it with the right character. In that case, I'll just populate this particular string rightly with C, right? Or this particular index with C. However, if it was not the right, if it was not the last character, then I need to update my remaining, or I need to tell I need to tell the program that I have some remaining frequencies of the of the current character. So I'll do that. So I'll tell them that okay, the remaining character which I have is C. Once I'm out of this loop, then I definitely have constructed my string. Now it's possible that the actually the reverse of the string is actually greater than the current string. So just to get rid of that kind of a scenario, what I'm doing is I'm firstly taking the reverse of it. Then whatever the maximum is out of the two, I'm going to print that. So this was the entire logic for problem C. Any doubts so far? Okay, cool. So let's move to problem D then. So where's problem D? Do you guys want me to discuss the problem D1 or up till C is fine?
कर दो सर.
Okay. Okay, so problem D1 is that you are actually having two CPUs, right? And you are having K programs. Now, for on the two CPUs, you'll have to perform or have to run this program sequentially. So firstly, you'll have to run the program A1 or whatever sequence is given. So it could be the case that A1 actually states that you have to run the program 0, then A2 states that you have to run the program 2, then A3 might be like you have to run the program 0 again. So this kind of a scenario would be given to you. But when you run a program on a PC that initially had already run the program, right? So let's say in the PC 0, you already ran the program A1 and after that you didn't run any program. Now, if you run the program A1 again on that particular PC, in that case, it will take you only hot time. What's hot time now? So hot time is actually the time it takes for a program to run. If you have already run it before on the same PC, and after running that particular program, you didn't run any other program. So by that I mean that if you ran a program A1 and then you ran a program A2 and then you ran a program A1, so that won't be considered as a hot time, right? Or it won't take hot time to run the program. But if you ran the program A1 and then it was idle maybe, or it automatically began running the other program A1 as well, in that case hot time would come into consideration. Now if a program was run or a CPU was running a program A0 and then you run a program A1 over here, or any program AI which is not A0, then it will take cold time to run over that, right? So this is what is given to us. Now we can run any program on A1 or A2 as required. At the end we have to tell them that what's the minimum time required in order to run all of these programs sequentially. So this is the problem. Now let's start with the recursive approach, and then I'll tell you how to reduce the complexity, or how to use or how to save the state in such a manner that it's doable in order of nk time. Over here, this is the D1 problem. So over here, n and k is actually limited to 5000. So if you multiply n into k, then also it will become 25 into 10 to the power 6. So that is something I can actually store, right? This is not a very big number and it is a number which I can store. Cool. So back to the iPad. So what I'm saying is that I have two CPUs. This is CPU 1, this is CPU 2. So I can say that, okay, I ran the program, let's say on CPU 1 I ran maybe A0, then on CPU 2 I ran the program A1, then on A0 itself I again ran A2, then on then A3 also I ran over here, then I again wanted to run A1 maybe, like, so I ran A1 over here, then I wanted to run A2, so I ran A2 over here. So this is the way I'm gonna do it, right? So the entire point is that can I do it with a recursive approach? So in recursion, I can say that what was the last program on A1 or CPU 1, last program on CPU 2. I can talk about the current index or the index of the current sequence that you're checking, and what next. Yep, so that's it. So over here you'll check that if the current index is equal to the last program that ran on CPU 1 or last program that ran on CPU 2, then it's all obviously beneficial for you to run the same program on that CPU. So now let's say the current index requires me to run the program maybe AX, right? And AX was already ran before on CPU 1. Then it obviously makes sense for me to run the program AX on CPU 1 itself. So I'll say that, okay, the recursion would now say, and since you were already running this program in a CPU and you're again running the same program, so it will take you hot time, right? So I'll say hot time to run this program or program AX, right? Plus whatever the recursion would give me for. So I'm running the this program on CPU 1, right? So I'll write that, okay, CPU 1 now is AX. Then last program to run on CPU 2 would be as it is, and then the index plus 1, right? At the end also, if the index is equal to n, or we have reached the end of the array, in that case I'll return 0 because 0 time is needed to run 0 programs. But what if it's not equal? If it's not equal, then I can say that I need a cold time plus recursion of, since I'm doing a cold time, now I can run this program on A1 or A2. So I'll have to check both the scenarios. So I'll have to check that if I'm running on A1, right? So last time, okay, let's say AX is running on A1 or the CPU1, then the CPU2 would be as it is. So last program ran whatever it was, and so on, right? Plus, okay, so cold time plus, you have to select the minimum of this, or you can run the program on the second CPU, you know, the rest of the parameters. Up till this point, is everything clear? Guys, is everything clear up till this point?
Yes, sir.
Okay, cool. So how do we memorize it? Now, in order to memorize it, I will have to store three values, right? So I'll have to store the last program on CPU1. So let's call it LPC, last program on CPU1, LPC1, right? I'll have to memorize LPC2, and I'll have to memorize LPC, oh sorry, not LPC3, but index, right? Index. Now the index would go from 0 to n. The program counter would go from 0 to k. This will also go from 0 to k. So this would become a k square n, or in the other terms, because k is all can be equal to n, so it would become an n cube logic. That would give a TLE, right? Or it would give you a MLE. Actually, you cannot store these many values. So is it possible for you to predict the program that was running on CPU1 with the help of one of the programs? So let's say if I give you the program that was running on the CPU1, can you predict what the program was running on CPU2? Can you do that? So that actually is doable, because if I'm standing at particular index, let's say I'm standing at the particular index 1, or I'm standing at any random index I, then obviously the program at I minus 1 needs to be running at some sort of a CPU, right? Because we came to the index I only after running the program at index I minus 1, right? So that definitely would be running at some of the CPUs. So this is one knowledge I can use. So now let's say I get to this point, and I know that the program at the CPU 2 is, let's say, okay, or the program at CPU 1 is, let's say, A0 or AI, right? Or AK you can say, because I is already being used. And you know, standing at I, one of the programs that would already be running is A of I minus 1. So you can say that, okay, the program running at CPU 2 was A of I minus 1. So this information can be stored. So if I use this, so what I'm saying is, because by knowing what the index is and what the program at CPU1 was at the previous location, I can get what the program at CPU2 was. So the program at CPU2 simply was the program at I minus 1, right? Now I can store these values into a DP array, or I can memorize it, and hence I can get to the solution part. So I'll now be explaining the approach. Now, since the approach is explained already, I'll explain the solution directly. Yeah, one thing tricky over here is not tricky, but actually this is the first time I'm seeing this kind of a thing. So I had actually done the same approach over here as well, but it was still giving me a TLE on pretest 2 itself. Now the reason it was giving a TLE was that I was actually initializing the DP array over. It was a global array actually, but I was mem setting it, or I was setting all the bits of it to -1. So probably they were taking a scenario wherein the number of test cases was actually pretty large, right? And because the number of test cases were pretty large, it was doing this particular operation for like it would do this for 25 in, okay, so it is 5,000, yeah, 25 into 10 to power 6 times, right? And that was giving a TLE. Now since they had designed this particular program in that way that the number of test cases can actually be huge, so this was bound to give a TLE. So in order to get rid of such scenarios, you can actually use a dynamic values. So then I used the DP vector itself, wherein I could populate it with the required values of n and k. So let's get down to the solution. So in the solution, firstly, I'm taking a pair of integers, right? A vector of pairs, I'll say. So it will store the cold time and hot time, right? And then it will start running the loop. Now before it starts running the loop, I know that the program 0, or before I start running the recursion, I know that the program 0 would get installed, let's say at any computer, but it always would need a cold start, right? Because before that there was no program running on any of the CPUs, so there's no point of considering that if it's possible for us to do a hot start or not. It'll definitely start with the cold start itself. So that's what I'm assuming, and that's why I'm saying that firstly, whatever cold start time is required for running this program 0, that would definitely be there, plus whatever time is required to run the program from the index 1 till n. That's what I'm going to calculate over here. So there are two parameters. One is the index and the other parameter is the last used. So the last use actually over here defines that whatever program was used in the last PC that was not running the program at the location idx -1 or the index -1. So cool. Over here, firstly, I'm checking that if the values had already been stored. So -1 is the dummy value. If the value is not -1, then definitely we have populated it. In case we have populated it, so we'll return whatever the value we had already calculated. If that is not the scenario and the program at the current location is similar to the program at the last location, so we were already running it in some sort of CPU, right? So in that kind of a scenario, what I'll say is that I'll return the value that would be the hot start time for this particular program, because now I'm running it at the same CPU which was running this same program earlier, plus a recursion of whatever time is required to start like use the next programs, right? Or if the last used value is also is similar to the current program, in that case also I can run it in the same CPU, right? So in that case also I'll utilize the hot start for this. Else what I can do is that either I can run it in either of the CPUs, right? So I can run it in CPU 1 plus or CPU 2, and it would require me the cold start time. So cold start time, whatever the minimum of the two is, I'll be giving it that. At the end, it's fairly simple. You just have to print it. Cool. So this was the intuition. Now, apparently this program, like if you're targeting D2, that was actually solved by 800 people. That actually requires an order of n logic, because over here n and k both are 3 into 10 to the power 5. But since I myself haven't done it, so I can't recommend you a good approach for this. Cool guys, so that was it for the session.